Hello everyone. I am CHVSS Sudheer, Assistant Professor, Department of Civil Engineering at Institute of Aeronautical Engineering, Hyderabad. So today we are going to discuss about the properties of the fluid and in which we are going to cover the following concepts like the types of the properties such as the mass density or specific mass, weight density or specific weight, specific gravity or relative density, surface tension, capillarity and viscosity. So coming to the properties of the fluid, basically a property can be defined as any character of a substance of that particular system. So what are the basic common properties are temperature, mass, weight, velocity, viscosity are the examples of the properties. And these properties are basically divided into two categories. One is intensive properties and as well as extensive properties. Intensive properties are those independent of the system, such as temperature, pressure, and density. Coming to the extensive properties or extrinsic properties, they are dependent upon the size of the system. So here we can observe some of the basic examples of both intensive and as well as the extensive properties from this figure. Now coming to the basic properties which we come across generally in the fluid mechanics concept are, first one is that mass density. As we know that it is defined as the ratio of mass of the object to the corresponding volume of the system. So basically it is denoted with the rho, a Greek letter. It is also called as specific mass and its units are generally represented in kilogram per meter cube in SI system of units and gram per centimeter cube in CJ system of unit. So typically for a water we can take the mass density as 1000 kilogram per meter cube or 1 gram per centimeter cube in CJ system for our problems. So, but for gases, the density is readily changes for change in the temperature or changes with respect to the pressure. Next property is that weight density. It is defined as the weight of the object to the corresponding volume of the system. It is generally denoted with the letter W. And its units can be expressed as Newton per meter cube in SI system of units and gram per centimeter cube in CJ system of units. Typically for water, we can consider the specific weight as 9810 Newton per meter cube for problems. And next, the relation between the mass density as well as the weight density can be represented as W is equal to rho into Z, where W is the weight density or the specific weight of the given object and rho is the mass density of the given object or the specific mass of the given object and G, that is the acceleration due to gravity. Another property of the fluid can be taken as specific volume, in which just it can be taken as a inverse of the mass density. That is, it is defined as the ratio of volume of the system corresponding to the mass of the system and it can be represented in the units of meter cube per kilogram. Next, the most important property of the fluid is that specific gravity. It can also be called as relative density. So basically, it is defined as the ratio of mass density or the weight density for the given substance over the mass density or the weight density of the standard liquid or the standard fluid. It is generally represented with the letter S. So for liquids, the standard fluid can be taken as pure distilled water at 4 degrees centigrade, and for gases the standard fluid can be taken as air at the room temperature. Since it is a ratio of the densities, either mass density or weight density, and therefore its units are dimensionless. So mathematically we can express the specific gravity as follows, that is mass density of the given fluid, either it is a oil or liquid of some other type, to the mass density of the standard liquid, or the weight density of the fluid over the weight density of the standard fluid. And also the another advantage of the specific gravity of the property is that it can be useful for the estimation of the mass density or the weight density of the liquid which is unknown, provided the specific gravity is known as shown in the formulas. So with this we had studied about a basic few properties of the fluids which we come across in our fluid mechanics course. Following are the references which we can refer for the fluid mechanics course for easy understanding and doing the problems. These are all the topics which we are going to cover in this today's session, which covers about the definition of the fluids, differences between the solids, liquids, and as well as the gases, and what type of the forces generally we can observe on a typical liquid, on a typical fluid particle, and what is meant by normal stress as well as the shear stress. So coming to the definition of the fluid mechanics, it can be defined as the object which can deform easily under the application of the shear stress, or in simple words we can say that an object which is capable of flowing can be defined as a fluid. So this fluid mechanics, again it is a branch of applied mechanics in which it deals with the behavior of the fluid particles, that is either liquid particles or gaseous particles, either in the rest position or in the moving position. So if the liquid particles which are in the rest position, and if those properties are identified, and if a detailed study is conducted, then it can be called as fluid statics or hydrostatics. On the other hand, we can say that if the liquid particles are moving and those properties are studied, then it can be treated as an fluid dynamics. How we can identify the differences between the solids, liquids, and gases? So basically coming to the solids, we can say that the intermolecular distances between the atoms which are in the solids are very small, which are in the range of 0.3 nanometers, and therefore they have the high density. And as they are having the larger volume in rate, they are incompressible and they possesses less kinetic energy. So with these basic properties we can identify it is a solid. Next, coming to the liquids, we can say that the intermolecular distances between the particles which are in the liquid for the solids as well as the liquids can be similar, that is at a distance of 0.3 nanometers. But coming to the another differences, it has the high kinetic energy and they are hardly compressible. And the last, how we can identify it is a gaseous substance. So basically the intermolecular distance is so large, is in the order of 3 nanometers, and it has a high kinetic energy and they are more compressible. So due to the more intermolecular distances, then we can say that it is having the low density. From these figures, we can identify the arrangement of the intermolecular atoms within the given object. So firstly, if we are going to observe the solid particle, we can say that, as we say in the previous discussion, that the intermolecular distances is so small within the range of 0.3 nanometers and they are having the high density. Therefore, their bond strength is also very large. And the arrangement of the atoms in a solid particle is very regular compared to the liquids and gases, which we can observe from this figure. Coming to the right figure, which we can see the examples of the solids, liquids, and gases which we come across from our day-to-day life. For the solids, we can take the solid like examples are gold or bricks or wood. Then coming to the liquids, which we can say like milk, blood and coffee, and some other are the examples of the liquids. And the gaseous substances like air and helium, xenon are the examples of the gaseous substances. Generally, any body will be experiencing different types of the forces at a different position. But coming to the fluids, what are the basic types of the forces which we are going to see which are acting on a fluid particle? So for that, let us consider a small elementary cross-sectional area which can be represented as delta A as shown in the figure. And coming to the forces, since we can resolve in both components, that is x as well as the y, we can say that the forces which are acting on the x-axis or which are in the x direction, parallel to the x direction, those forces are called as shear forces. And these forces will cause the shear stress because they are going to act over a particular cross-sectional area, that is delta A. And coming to the next type of the force is normal force. These force will be parallel to the y-axis or perpendicular to the elementary cross-sectional area delta A. And these forces causes the normal stress on the body. So basically, as we know that stress is defined as force per unit area. So therefore, if it is of the horizontal direction or the force which is parallel to the x-axis, then we can say that shear stress, which is that force corresponding to that x-axis over the cross-sectional area. And the normal force or the normal stress, which is defined as the normal force that is acting over the elementary cross-sectional area, is called normal stress. So from this we can conclude that we had seen what are the forces acting on the fluid particle and the basic differences between the liquid, solid and as well as the gaseous particle. With this, we are going to confine for only the liquid particles, and we are going to study the behavior of the liquid particles both in the rest position as well as in the moving position in the coming on videos. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.